we're going to go on and get started with this here today. Now, what we're looking at and what we're starting is chapter 4, polynomials. Now, for the most part, all four of y'all and the one who's missing, well, one of the two that's missing, finished your test. Y'all did fine. Most of y'all did pretty well on this here, and I'm just going to say this because mainly I've said it the other hours. Okay. Yeah. Y'all do fine, especially with the review sheets. You actually use the review sheets for what they're meant for. You actually do them beforehand, not just wait till I go over it with y'all to write it down. Because waiting for that point, it's meaningless. It's just numbers on a page. So, again, good job with that. There's probably a few things here and there that just number switches. Little things here and there. You can always do the makeup points and earn back half the points you lost. And you probably, for those of you who've been looking at wind gauge, P chapter test going on out. Does anybody have a guess what MUP is? Makeup points. So I'm putting that in there, so if you do the makeup points, it'll go from a 0 to a number, and it's going to say it's, I don't know if it turns it a different color for y'all, it does for us, because it's out of 0 points, all of those are out of 0, so it's just adding it to it. So there's that. Now, chapter 4 is polynomial functions. What we've been talking about, quadratics, are considered a polynomial function. Linear functions, talking about equation of a line, are polynomial functions. So we're going to be talking about this here, really anything of a polynomial function. Now, this here is the general form of any polynomial function we could possibly have. So we have this here to just write any polynomial function of degree n. We can define it as this here. It's just talking about any and all. Now, there's 4 specific ones we'll look at. Well, 5. If the degree is 0, that's really saying whatever variable we have is to the 0 power. And anything to the 0 power is 1. So we really don't have a variable. It's just f of x, or y equals a number. It's a straight line, flat line. Now, when we talk about having a degree 1, it's a linear function. Linear function, talking about an equation of a line. Degree 2 is a quadratic. That's what we covered last chapter. Quadratics are degree 2. Their biggest exponent is a 2. When the degree is 3, we call it a cubic because the biggest exponent is a 3. And the same thing with 4. Degree 4 is a quartic, and we have an example of these here. Questions on any of this so far? All right. Standard form, writing the polynomial in order of decreasing degree from highest to lowest power. So we write the variable with the biggest exponent first, second one next, third, fourth, going on, decreasing power. And the leading coefficient, the number in front of the variable with the biggest power, is the leading coefficient. We take the sign with it as well. Questions on any of this so far? Okay, now, again, I had y'all write these down earlier because when we talk about what is a polynomial, is it a polynomial, trying to classify it as a polynomial, sometimes it's good to define the characteristics of what it is so that we can know it and when we see it. The other way, I think, is a little bit easier with polynomials, is saying what it's not. Because if it's one of these things, it's not going to fit. It's not going to fit that category. It just doesn't work that way. Yes? And I mean, you can do this with anything. So with classifying types of plants, like we can look at the characteristics. What does it have? Does it meet these criteria? Or we can go the other way and say, does it not meet these? If it meets any of these here, if the exponents are negative, if the exponents are fractions, if variables are inside a radical, if variables are multiplied together. Now, when we say these here, exponents aren't negative, which means, I can't have x to the negative 2. That would be a negative exponent. Exponents aren't fractional. I can't have 1/4 as a fraction. I can't have 1/4 as a fractional exponent. Variables aren't inside a radical. I can't take the square, have the square root of x. Variables aren't multiplied together. Now this one here is a little misleading because x squared is technically x times x. That's not what we mean. What I mean by this here is saying x times y. We don't have two variables being multiplied together. We don't have that set up. Now there's actually two more. I need to fill in the last one. This one here, variables can't be in the bottom of a fraction. But really this one and negative exponents actually go together. Because if an exponent's negative, the way we make it positive is move it from the numerator to the denominator. So really x to the -2 is really 1 over x squared. Those kind of go hand in hand. I do need to add one. Variables can't be in the exponent. Use an S. Exponent. Yeah, I think there's supposed to be an S in there, but that's fine. Exponent. E-X-S-P-O-N-E-N-T, exponent. We can't have a variable in the exponent. So what we're talking about with this here is like 3 to the x. This here is actually classified as an exponential function. And the rate of change, our slope for an exponential function, we don't have one. Because if we think of the numbers for this here, well, 3 to the first is, because when x is 1, it would be 3 to the first is 3. When x is, so the next one would be 2. 3 squared is, 3 cubed is 27. Then 80. The amount of change from one to the next is increasing faster and faster. It will take off. That's what we call an exponential growth. Questions on these here? So, the first thing we're going to do is decide whether each function is a polynomial function. So if I look at this here, -2x cubed plus 5x plus 8, is this a polynomial function? Yes. Yeah, because we could go through the list. Variables and exponents? No. Negative exponents? No. Fractional exponents? No. Variables inside of radicals? No. We don't have two variables being multiplied together, and we don't have a variable in the bottom of a fraction. So, yes. Okay, this is a polynomial function. If so, write in standard form. Is this in standard form? Because what's the biggest variable? Or what's the biggest exponent attached to a variable? 3. The next one is 1, and then our constant term, yes? Do we have x to the third first? Yeah. Yeah, it's first. You're good. And then our next one would be x, and then we have our constant term. So this is in standard form. So we don't really have to do anything there. On the homework, you would just end up rewriting it back out exactly as it is. So the next thing we need to state is the degree. What's the degree of this function? The degree is the biggest exponent. So it's degree 3. Type is almost cubic. It's a cubic function. And leading coefficient, negative. Because the leading coefficient is always going to be the number in front of the variable with the biggest exponent. That's it.
So like on B, that would not.
Is the radical, what's inside the radical, the 2 or both the 2 and x to the 4th? It's just the 2. It's just the 2. So this here is going to be an if it had done that, then yes, it would not be a polynomial function because both of those would be contained inside the radical.
So we really just need to watch how far the square root goes.
And if you want to make sure, especially when you write these out, to do a little drop down like that, you can. Sometimes I will write those, kind of put that just so as a reminder to myself, or just saying it's just the 2. That's also part of the reason we put I front in front of it, just so we know it's not connected to it. But you can write it in either way. So this one here we can say is definitely a polynomial function because we only have whole numbers, we only have integer numbers in the exponents. Because we don't have variables, we don't have negatives, and we don't have fractional exponents. We don't have a variable inside a radical. We don't have 2 variables being multiplied together. And we don't have a variable in the bottom of a fraction. So, okay, so it is a polynomial function. Is it in standard form?
No, you have to have to.
So we need the square root of 2 x to the 4th to go first. Then what? Yeah, negative 0.8 x cubed, and then minus 12. And we could say that this is g of x. It's just a way to name the function. Degree. Type. Quartic. Quadratic is degree 2. Quadratic is degree 2.
Wait, is that an S and then a C at the end?
Yes. Quartic. And leading coefficient. Almost. Radical 2. Square root of 2.
Okay, so why did the 2 have to go front?
The square root of 2?
Oh.
Yep, because we want it in decreasing power. So the biggest exponent goes first, second biggest goes next, third, fourth, and decreasing on. If we're missing some, because here we've been, on both of them, we did miss the x squared. If it's not there, we're not going to list it. We don't have to list it in this case. There are other spots throughout chapter 4 that we will have to put them back in as 0 times whatever it is, but at this point we won't. Let's look at C. Yep, so this is, no. Huh? So the instruction, decide whether each function is a polynomial function. If so, if it is, then, yeah, here it's not, so it's just no. How about the next one? Yep, we have 3 to the x. We have it as an exponent. Yep. So we can go on and just look at these here. So number 1, is it a polynomial function? Yes. It's not in order, so the correct order would be minus 5x plus 7. Because going through our checklist, it does not, it pretty much satisfies all of them if we look at the don'ts or the nots, because it doesn't make any of them. Now, the degree is 2, which makes it a quadratic. There's a reason behind it. It's probably dealing more from the fact that it comes from the Arabic language. All algebras that we get is from the Arabic. Leading coefficient would be? Yes. Because leading coefficient is always going to be the number in front of the variable with the biggest exponent. It would. Now, coefficient is just the number in front of the variables. Leading coefficient, yep. No. That was nice. And the last one. to the fourth.
Minus -6.
Almost. Cubed minus 6x. Yep. So the 3x. Okay.
Oh, I forgot the exponents go in order.
Yep. Exponents go in order. Exponents go in order of decreasing power and technically in alphabetical order. So if we had x and A's bigger exponent would go first. We would deal with the powers of A and then deal with the powers of X. Degree. Type. And I know that y'all probably don't care, but number theory actually addresses how we write. There's a whole mathematical category or subject behind how writing all this out is a part of number theory. Now, evaluate this when x is 3. So what are we going to do? Yeah, we're just plugging in 3 for x. And I would always put the number that you plug in for a variable in parentheses, especially when you type it into a calculator, because, well, -4 squared, we know is -4 times -4, which would be 16, yes? In the calculator, if you type -4 squared without parentheses, it gives you -16. Because what it sees it as is -4 times 4. It doesn't see it as -4 as a whole squared. So whenever, especially if you have negatives you're trying to square, you need to put it in parentheses. So the one we're looking at, trying to get to the right page. So we can do 2 times 3 to the fourth minus 8 times 3 squared plus 5 times 3 minus 7. Well, for the most part here, yes, because it will see it as 23, not this. Now, at some point, probably between middle school and now, I don't know why I keep resetting back to that, but okay. Your middle school math teacher, Ms. Kendall, I've told you don't use X. I don't think I've actually told you all that because you didn't have me for geometry. And you've probably said okay and just moved on. But the reason we can't use X as for especially trying to factor or do anything like that is these two calculators need a value for X. The ones that can do it, the TI-89 Plus and some of the Inspires can do it. You have to actually pull up a special function and then define that you're talking about X, talking about in terms of that variable. And the reason for it is because these need a value. Now what we can do is 3, and this button down here, STO, S-T-O, is telling it, I want you to take the value of 3 and store, S-T-O, store X. If I hit X, it's going to say it's. So what we could do is 2x to the fourth minus 8x squared plus 5x minus 7. So we took whatever number it is. So let's say -3. Store variable. So now it's going to think that it's -3. And what's nice is I can actually scroll back up, enter, pull it back down, enter. Yep. And this here will take care of the negative. We don't have to worry about the -3 to the fourth and putting it wrong. This is why we never use it, because it's always going to be set to something. even if you reset the calculator, it's going to reset it back to x equals 0. It'll reset it to a value. So no matter what we do, x in these calculators will always have a value. It'll never be just a variable for the 89 or the 30xs. Questions on this here? We all need to see another example of one of these. Last thing we're looking at is in behavior of polynomial functions. In behavior of polynomial functions. Okay, I have a decent bit more time than I did in the other hours. I'm going to delve a little bit deeper into this. And when we talk about in behavior, it's more talking about what it's going to do eventually, going out. If we extend the x-axis out and just kept going indefinitely in both directions, these polynomial functions are going to behave in one of 4 ways. Now with our quadratics, they were a U-shaped graph, yes? So they either both ends went up or both ends went down. And it works with any polynomial function. So y equals x to the 4th minus 3x to the 3rd plus 5x squared minus 6x plus 3. I have no idea. Okay, it'll look like that. Let's see here. Because I'm just messing with this function at this point. Delete, graph. Okay. Yeah, I'm gonna have to look. I would have to look some of them up, but because we could have a quartic function that would do this here. There's stuff and different things the way that they'll go up and down between the 2 spots, but any even degree polynomial function is either they're both going to end up going up or both ends are going to go down. And what happens in the middle can change depending on how the function's set up. I have a feeling. I wonder. Nope. And cube. There we go. As we can see right there where it crosses the y-axis, it does have a little bit of a curve to it. But it's still, both ends are going up. And that's the big thing with in behavior. If it's even, they're either both going to go up or they're both going to go down. Now what happens in the middle is going to change, as we just saw. Because it didn't give us that nice little U, it actually gave us a little bit of a curve. If we could get something that looks more like a W, there's different ways that this can behave. But eventually both sides are going to go up or both sides are going to go down. Now the big kind of what if, why does that matter, is if this is the graph that we pull up and it turns out that both of them, here's what we have, yes? And we know that both should go up. What do we know is going to happen somewhere off over here? It's going to go back up, yes? And we solved quadratics by graphing. We looked for where it crossed the x-axis. So normally, looking at this here, okay, I've got solutions here, here, and here. We'd call it done and move on. But now that I know about in behavior, that it's should both be going up, I know that either A, I need to look this direction for another solution, or if it turns out they're both going down, I need to look this way for another solution. Does that make sense? And that's why these are helpful, is getting us an idea of how the graph behaves, how it works, what solutions we should be looking for. Now there's one of 4 cases that we have. These here. Now a function, its degree, the biggest exponent is either going to be odd or even. Only 2 cases that we have. There is a number that's neither odd or even, which is 0. Yes? But if we say that the degree is 0, that means it's a constant function. It's just a line. It really didn't have an in behavior. It's just a flat line, doesn't do anything. So really, all of our degrees are either going to be odd or even. odd or even. And the other thing that we look at is the leading coefficient. Well, leading coefficient is either positive or negative. And really that's dealing with our reflections across the x-axis. Because when we talked about standard form, any of those, if A was negative, it's a reflection across the x. So it's just flipping it. And these here are our main ways that we'll answer these questions. Are these parts here. And we got one more. Now with odd functions, we really haven't talked about, you really haven't encountered too many odd functions of degrees, except in Algebra 1. Because a linear function is x to the first power, yes? X to the first, so the degree is 1, which means it is odd, yes? And what these are both saying is that as x approaches negative infinity, and x approaches infinity, here, as x approaches infinity, as x gets bigger, f of x, or y, does what? It's either going to go up or it's going to go down. So it's saying as x approaches infinity, the y values go towards infinity, positive infinity. As x approaches negative infinity, f of x approaches negative infinity. That's all it's saying. Questions on this here? You ready for this here? It's not as hard as you think it is. Looking at this function here, what is the degree? The leading coefficient is indeed negative 0.5. Now the degree would be even, yes? And the leading coefficient is negative. So we have even and negative. Since I know it's even, that means the function either both are going to go up or both are going to go. And if it's negative, it means they're both going down. So what that tells us is for our answer that f of x is going to approach negative infinity. And f of x is going to approach negative infinity. Because with even, f of x, they're going to approach the same thing. They're either both going to approach positive infinity or both going to approach negative infinity. As x approaches positive infinity and x approaches negative infinity. Now the x approaches positive infinity and x approaches negative infinity, the second half of these, that part will always be there. We will always include that. What f of x approaches will change depending on which one we're looking at. And what I mean by that is here, since it's even and negative, they're both going down. So eventually they will both head down. So f of x is going to approach a negative infinity in both cases. But as x approaches positive infinity and x approaches negative infinity, this part, we will have those in both of our answers every time. Questions on this here? So really the only thing that's changing or will change is these here, because we might not have both negative infinities. We might have one negative, one positive, or one positive, one negative, or two positives. But that's it. Questions on this here? So this here, what is the degree? Which is odd. Leading coefficient is, so again we have, now with odd, they always end up going in opposite directions. So if you want, what you could do is start off by saying f of x approaches positive infinity and f of x approaches negative infinity, because we know those are going to go in opposite directions. As x approaches, Now again, I just threw down f of x approaches positive infinity, f of x approaches negative infinity. Now how we set it up on the one before, we had positive infinity to finish out the top line and negative infinity to finish out the bottom line. It's not necessarily that way. Because if we look at the general case, leading coefficient, so odd, negative, f of x approaches positive infinity as x approaches, and f of x approaches negative infinity as x approaches positive. So this one here is negative infinity, and this one is positive. Because eventually, we're going to have it going up, something in the middle, and then it's going to go down. Because our general normal parent function for the cubic is this. So we're looking at something like this here. You don't have to fill those graphs in. I'm just throwing those in there just as a visual aid. Any questions on this here? Because again, that's the only answer we're looking for. If you have it flipped, you have the, instead of having the one that we wrote on top on the second line, that's fine too. Let's look at one last one. What's the degree for this here? 3, which is odd. Leading coefficient is 0.25, which is positive, yes? Well, since it's an odd function, f of x is going to approach infinity, and f of x is going to approach negative infinity. As and if we look back at the chart, f of x approaches positive infinity as x approaches positive infinity. That's something like this here. Now, I had one of the previous hours ask, can we do these in the graphing calculator? And the answer is yes and no, because the graphing calculator won't give us this. But if I pull the graph up, clear this out, 0.25 x to the third minus x squared minus 1 graph. So the last one we just did, as x increases, as x approaches positive infinity, the function is going up. And as x goes to negative infinity, it's going. So it can give us a visual aid to see what it is. That is, as long as it doesn't take some turn and just start going down or up outside of this, we do get this here. Now, one thing I could do is say zoom. Well, we can do zoom out. There's one below it. Zoom stat, zoom fit. I would not use zoom fit too often because it doesn't give us a good picture of it. Zoom 6 gives us a better idea, a better view of it. It's just a standard picture. Questions on this here? That's it. As a reminder, 9 and 10, which are on there, is the error correction part of it, which means you have to find the error and fix it. So you need to state what they did wrong and then correct it, okay?